In this lesson, we define meanings of collinear points and establish criteria to prove that the given set of points is collinear. Here we are given 3 points A, B, C, and we will use different methods to prove that these points are collinear. Let's get started and use the method of slopes to prove that these points are collinear. So using slopes, using slope formula, here the point A has coordinates 0, 4 and point B has coordinates 1, 7 and third point C has coordinates 3, 13. Now if the points are collinear, means if all the 3 points A, B, C lie on the same line, then slope of AB and slope of BC must be same. Not only slope of AB and BC must be same, rather all possible 3 slopes, slope of AB, slope of BC and slope of AC, all must be same. So let's find out slope of AB. To prove that A, B, C are collinear points, we will prove slope of AB is same as slope of BC. So let's find out what is slope of AB. As slope of AB, what is the formula is y2 minus y1 over x2 minus x1. For starting point, we usually name the point as x1, y1. Let's name this as x1, y1 and name this as x2, y2. So once we have named, we know that y2 is equal to 7, x2 is equal to 1 and x1 is equal to 0 and y1 is equal to 4. So let's substitute the values and this will give us 7 minus 4 divided by 1 minus 0. This is equal to 3 over 1, which is again equal to 3. And similarly, we will find slope of BC, and we use the same formula, y2 minus y1 over x2 minus x1. But what happens this time, now the point B is named as x1, y1 because that's the starting point for this slope, and this will become x2, y2. So now we will use the value of y2 as 13. So substitute the values and we will have 13 minus 7 over 3 minus 1. 3 minus 1 and 13 minus 7 would be equal to 6 over 2, and this is equal to 6 over 2 will be equal to 3. If slope of AB was named as M1, then all these are values of M1, and if slope of BC is named as M2, then this is M2 and this is M2. As you can see that M1 and M2 are same. This means that both slopes are same and points A, B, C belong to same line. As M1 is equal to M2 with B as common point for slope of AB and BC. So our conclusion is that ABC, AB and C are collinear points. So this is one criteria we use to prove that the set of points A, B, C are collinear points. And it should be noted that B is a common in both slopes because two parallel lines might have the same slopes as well, and in that case the pair of points may not be on the same line, but because B is a common point in both slopes, it means the lines cannot be parallel. Both of the segments for which we are calculating the slope are actually part of the same line. So now we will use second method, and second method is a vector AB is scalar multiple of vector AC. This time we are going to calculate the vector AB and we are going to calculate the vector AC, and we will show that one vector is a scalar multiple of the other vector. So let's find out. Given points are again given points are A with coordinates 0, 4, B is another point with coordinates 1, 7, and C is with coordinates 3, 13. So in order to find out the vector AB vector is a displacement vector, and we can either find out directly by subtracting components of A from B, but let's do the full procedure. AO plus OB is equal to OA is equal to 0, 4, so AO will be 0 minus 4 plus OB will be 1, 7, and this is equal to 1 minus 0 and 7 minus 4. So this is equal to 1 and 3. So this is a displacement vector AB, and now let's find out what is AC. AC is equal to AO plus OC. So this time AO, like before, is again 0 minus 4. Just change the signs of position vector of A, plus OC is same, that is 3, 13. And now 3 minus 0 and 13 minus 4, this is equal to 3 and 9. Is there anything which we can take as common? That is 3. If we take 3 common, inside we will have 1, 3. If this is named as number 1 and this is named as number 2, and if we continue to write this as AC, this as AC, this as AC, and of course we will separate with the semicolon, and let's label these with their proper name, AB, AB. And here from 1 and 2 we can, combining 1 and 2, combining 1 and equation 2, we have AC is equal to 3 into, instead of writing 1, 3, we will write its equivalent value from equation 1, which is AB. So this proves, this shows that a B vector and AC vector are collinear vectors, are collinear vectors because they perfectly fit into the definition of collinear vectors. Collinear vectors mean there must exist a scalar number, which is 3 in this case, so that the both vectors are scalar multiple of each other, which is the case here, are collinear vectors, and this proves that the point A, B, C are collinear. As a result, A, B, C are collinear points. And for third method, we can calculate the area of triangle ABC, and we will prove that the area of that triangle is equal to 0. And if that area is equal to 0, it means that all these A, B, C points are in fact points on the straight line. That is the only way they can have area included between them equal to 0. So we prove that area of the triangle ABC is 0 if ABC are collinear points, and we can find out area of triangle ABC. Area of triangle ABC is equal to 1 by 2 determinant x1 y1 y1 1 x2 y2 1 and x3 y3 1, where A has coordinates x1 y1, B has coordinates x2 y2, and C has coordinates x3 y3. We can take area of triangle equal to half of the determinant, and we will now replace 1 by 2 time, and this is the determinant, and x1 y1 are the coordinates of A, which is 0 4 0 4 and then 1, and next 1 7 and then 1 and 3 13 and 1, 3 13 and 1, and we will evaluate this determinant. And if we calculate the value of this determinant, expanding it by second column or first row, let's expand it by first row. So this will be 0 time 7 minus 1 time 13 is 13, and minus 4 times we multiply the matrix of cofactor. So this is 1 time 1, 1 time 1 minus 3 time 1 plus 1 into 1 time 13, 1 time 13 minus 3 time 7, and the first part of this expression is 0 anyways. Minus 4 time 1 minus 3 plus 1 into 13 minus 21. So if we expand this, this would become equal to 1 by 2, and minus 4 time minus 2 plus 13 minus 21 would be equal to minus 8, and we can see that this is equal to 1 by 2 times 8 minus 8, and this is equal to 1 by 2 times 0. This is equal to 0, and this is by expanding this determinant. And you can learn this expansion of determinant of order 3 by 3 from the chapter of matrix and determinants. It wasn't the intent to explain the multiplication and the expansion procedure for the determinant here in this question.